an eye on the pool today. I'm just going to create a pool, and after the after the lecture, inshallah. And if you guys are comfortable with Friday, I think we can go for Friday. This is one thing. I think that will probably solve our issue, that it will give you conflict-free week as well, and plus, it will also, inshallah, give you, a better, more relaxed environment for preparation. And the second thing I had in my mind is that because at the end of the day, this is more like it's a modeling course at the end of the day. So we need to in our exams, we bound to have questions where you need to model something. So we'll try to do a more like a a trial quiz or something, or trial assessment sometime during this week, where it's basically gonna be like one question, where you go ahead and draw something on a piece of paper, or using one of the online tools, and you basically submit the image into the system, right? It's because we want to try this so that we are comfortable that it does work, and everybody knows what to do. And so inshallah, for that we will do an exercise as well, inshallah, but I'll announce a time for that. It will be like 10 minutes max, 5 minutes, 5 to 10 minutes max, inshallah, not more than that. Any other concerns, guys?
About the lectures.
Yes.
Can you upload it in the Blackboard? Because it has a limit in Teams by 20 days, and it will be deleted.
The lectures, then the lecture notes are there in the Blackboard, right?
Doctor, can I comment?
Yeah, please go ahead.
The recordings are in files in the Teams. They are permanently saved there if you want to check them.
Oh yeah, Jazakumullah khair. I remember you sent me a message as well, right? Yeah, so the recordings are there, guys. So the recording are there. So this is perfect. Jazakumullah khair. Thank you very much. Okay. Now, shall we? Yes, Fahad, you're gonna say something?
No.
All good, right?
Yes.
Okay. Okay, perfect. So let's start, right? So inshallah, I'll make one or two other announcements about the project towards the end of the lecture. Maybe we can start, and we can take it from there. So let me start the recording, and then we'll inshallah, start this from where we stopped. Oops. Oh, we already have the recording going on. Sorry, I didn't realize that. Okay. I assume you guys can see my screen now, right?
Yes, it's busy.
Okay. Now, last week when we had our last lecture, we were talking about at a very high level concept that how we can design as a designer, or what are the things we should consider in addition to the basic concepts we learned in the first 3 to 3.5 weeks. That we need to, as a designer, develop applications which are flexible in nature, reusable, and efficiency. We try to achieve this. So we talked about flexibility, and we said that in order for us to have flexible design, this means that the systems are modular in nature. They have minimal dependencies between them, and so that if you make a change in one part of the application, the other parts are not really impacted. So we can continue this discussion, and we can talk about reusability and efficiency now. So again, this is a bit more high-level discussion here, but but it's just the concept we need to understand that that this is important for us as a designer to consider them. When we're designing applications, we may be interested in reusing them. So it may be of interest to us that we want to design an application which has a potential to be reused, and this reuse can be at an architectural or design level, It can be at a component level, or more importantly, it could be at a more like a source code class level. Of course, our focus at a detailed design is always going to be more like on classes and methods or functions and combination of classes or packages. So as a designer, you like to design your application in such a way that you are able to reuse individual classes, individual functions, or combination of these classes. And of course, you might be like to reuse your even high level subsystems and uh, you know architectures and so on and so forth. Uh, if you recall, I gave you an example of software product lines where you basically an organization has a range of products they develop, and these products have some common functionalities, and they are certain functionalities which are variable among them. So for such kind of systems, for example, reusability is an ultimate thing. They really want reusability because that's how they will be able to reuse their components, they will be able to reuse their source code, and they will be able to reconfigure it. But regardless whether you're developing a software product line or not, so you're going with SPLC software product lines or not, it doesn't matter, but you still are interested in having a design which is somehow reusable. You can reuse methods, for example. And if you want to, for example, make your methods reusable, first of all, you have to, for reusability to happen, you have to have, a complete specification. This means for a given method, you should know what are the preconditions, what are the post conditions. And this is very, very important because without this information, you cannot really reuse the methods. And then, inshallah, as part of this course, towards the very last, we're going to talk about software construction. And there we will talk about in detail, how really, a good specification looks like, what is the structure of it, what we have to think about it, how we define preconditions, how we specify preconditions, post conditions, so on and so forth. Of course, in addition to complete specification, you need to somehow also minimize. You cannot really avoid, but you need to really minimize coupling between classes, because once you're going to have a minimal of a coupling, it will be easier for you to reuse. Why it will be easy?
Doctor, you're muted.
Oh, sorry. Yeah. So why it will be reusable? Why is it will be easy for us to reuse? If we have, a, a class where basically you have, a minimal of coupling between them. What's a coupling? When I'm saying there's a coupling between classes, what it really means?
Connections.
Connections, right? Dependencies, right? So for you to reuse your component, your classes, you need to, or methods in this case, for example, you need to have a design in such a way that you have minimal interdependencies between different methods. Okay. Of course, how you can do it, you can make them static, as for example, they're just different tools or different solutions you have. So you may make your method static, for example, you can include parameterization. This means basically have methods functional and limit the number of parameters. All of this stuff helps, right? And of course, names needs to be more expressive. In other words, because it's going to be reused, so it will be meaningful to have, it will make sense to have meaningful names rather than having like a method called A, B, C, something like this, because without that, people will not be able to reuse your methods in the right way. And of course, you also have to explain your functionalities or algorithms you're using or implementing in that method so that other people can safely use it. Again, this is all boils down to your specs or specifications of your method. Why I'm interested in algorithms? Why I want to understand why I want to specify my algorithms, or some explanation about how the specific method is working. Why I'm interested in this? from a reuse perspective?
Maybe because when I return to it, I can understand how it's work, and if it's like compatible with what I need.
Exactly. So in other words, because you're gonna try and reuse this method in your application now, so you need to know exactly how this method really works, because maybe you don't need to have an access to source code, because probably you're purchasing from someone. It's quite possible, but even you don't have an access to the source code, you still need to understand how exactly it's going to work, what kind of parameters it will take, what kind of return values it will give, what kind of algorithm it's using, or how it's written. Because unless you understand the method, you will probably not reuse it, right? Because you want to make sure that the method you're reusing is actually as per your requirements for the new application. So there are some general pointers here, in a sense that when you're reusing your methods, of course you need to specify them, and you need to specify preconditions. It's some explanation of its algorithms or the functionality. You need to make the names more useful or meaningful, and of course you need to limit the parameters, and basically at the end of the day, don't have unnecessary coupling between them. Similarly, if you want to reuse classes, again, you need to describe your classes completely, because unless you explain your classes, the one who's going to try and reuse your class will not be able to comfortably use it, because he will not completely understand what exactly this class is doing. Of course, you need to have meaningful names. You need to have functionalities which are, again, meaningful. And another way of doing this is maybe you use the concepts of abstraction, and reduce the dependencies between classes. And of course, these are the certain pointers as a designer you keep in your mind if you are trying to make a design which is easy to reuse. Now let's look at a hypothetical example. That's a very simple hypothetical example. Now let's say I have come up with this application. This is my existing system. What's the meaning of this design? What it tells you when you read this one as a designer?
Doctor, I didn't think this design makes sense because the customer and the piano does not have any relation. And he said that the piano consists of customer or something like that.
He orders this. So this is again important thing. So we need to have captions here, right? So let's say customer orders piano, something like this, Again, this is an hypothetical example here, right? So it's a very hypothetical example. So let's say I came up with this design, right? Now, I want to reuse this class. Can I? Given the way I have designed it.
Make it item.
Make it the piano as an item. That's the suggestion, please.
Yes, make it item that I or that customer orders.
So no, again, let's look this is as a hypothetical example. Let's first of all, and let's look at this that maybe this is the way I designed it for some reason because of my requirements, right? Now I want to reuse this piano in my new application. So I have, for example, let's even call it A class, right? Doesn't matter. So I want to reuse my class A in my new application, but I'm not interested in this class, right? So is there any dependency problem the way I have designed here? What's the meaning of this one?
Aggregation, I think.
Yeah, so it means what?
It means that every piano has a customer.
Every piano has a customer, right? So
Yeah.
so this means when I have this means I cannot just take this piano class and and use it, because maybe from an implementation perspective, I will have certain things here which will make it, will ensure that there is a customer here, right? Maybe the way you construct, you have a constructed design in piano and so on and so forth. So what could be the solution here? There could be multiple solutions, by the way, here. How I can improve this design so that tomorrow for my warehouse application, I can easily go on and use a part of this system.
Separate the piano from the customer.
Separate the piano from the customer. Exactly. Somehow separate the piano from the customer. So maybe, again, this is not an ideal solution, but maybe we can do something like this, right? That we, rather than having this dependency, we can break this dependency. Now, of course, there could be other solutions as well, by the way. There could be other solutions. Yes, please.
Can I take the piano class and just refactor it?
Refactor it?
Yeah.
When you say refactor, it means what you're trying to do?
See what's compatible with me, and with what it is not compatible, I change it to make it compatible.
Yeah. Oh, okay. I got the point. Okay. So in other words, I adapt it, right? Right. Yes. So as I said, there are so many solutions. That's a valid solution, absolutely. If you have an access to the source code, probably you might be inclined to do that. Definitely, right? There could be solution where you basically can package them in such a way and design this whole dependency relationship in such a way that each one is kind of segregated. Like, for example, we will see very shortly that there is a design pattern which is called mediator design pattern, and this mediator design pattern actually is there for such situations where you want to somehow decouple the dependencies. Okay. We'll talk about mediator design pattern in maybe 3 to 4 weeks time. But we have solutions. Again, today aim is not to look at the solutions. Aim is to look at the problem itself. That if you want to reuse, you might have to reduce dependencies. And for you to reduce dependencies, you as a designer have to think about what's the best way to reduce dependencies. The good news here is that the concept of interfaces, the concept of abstraction classes, and these design patterns where people basically tells you how to structure your application, it can help you, and other design patterns as well. It does help you minimize the dependencies, hence make it a bit easier for you to reuse or make your design more flexible and so on and so forth. Everybody's comfortable with the concept itself. Today the focus is on the concept, that what as a designer you're trying to do. Some show of hands will give me a bit of confidence here.
Yes,
it's clear, Doctor.
It's clear. Yes. Thank you. Again, we want high-level understanding here today, right? We'll dig into it. We'll see what mediator is, or other design patterns are, and why one design pattern is different from other. We will learn, but when the moment you will learn it, basically, this lecture will fit in. But I have to have this lecture so that you understand the bigger picture. So in other words, you basically have to leverage, you have to use, you have to get benefit of the concept of inheritance or aggregation or dependencies. You have these relationships, you have these concepts, basically use them smartly. That's the whole idea. Another thing which is very, very important when it comes to design, and we have to really think about it and we have to consider it when we're designing our applications, is efficiency. Of course, we're trying to maximize our efficiency, so we want to make systems which are, works within a certain time constraint. Usually when it comes to efficiency, we have two dimensions which we are interested in as a designer. We are interested in a time dimension and we are interested in a space dimension. In other words, we are interested in systems which are, fast and it takes minimal space, right? Or the way you use the space is an optimal way. So efficiency is something which is very critical to designer as well, and you have to think about efficiency from both time perspective and space perspective. Ideally, in a very ideal world, we'd like to optimize this. Like we will really want to come up with this solution where basically, it kind of, gives us an optimal solution between this trade-off between space and time, right? So for a given system, based on your space targets and your time targets, there will be a place in a design where you say, now this gives me a near optimal or maybe an optimal solution to where I'm maximizing my time targets and I'm also, for example, maximizing my space targets or so on and so forth. So there are different ways people look at efficiency of time in a design. For example, as a designer, you have to think about the issue of flexibility and reusability. You have to think about, or identify your components or classes which are inefficient from a time efficiency perspective. And of course, you make targets or changes to improve efficiency. So basically, you are doing what? You are thinking of efficiency from the start. You cannot have efficiency as a afterthought process in a design. It's not feasible. It will not work. You cannot come up with a design and then think, now I need to look at time efficiency. No, you have to think about time efficiency from upfront, even from requirements time. You have to think about these at all phases of your development, because the reason is, if you're going to try to look for some flexibility, then the way you're going to try and maximize flexibility, it will for sure have an impact on time. Because if you're going to have, say, for example, from a flexibility perspective, from a reusability perspective, you make a system, such a modular system that, you divided them into 10 classes now, and each one is separate unit now. But from a time perspective, it for sure will have impact, because for a certain operation, it may have to go through 10 different method calls, and each method call is a cost to you from a time perspective. So in other words, you have to, kind of make again a trade-off of efficiency requirements during design. You might have to look for solutions which basically, kind of gives you again an optimal solution which is acceptable from a flexibility perspective and reusability perspective, and also from a time perspective. And you have to look at efficiencies, at your initial design. You have to improve it, and so on and so forth. Are you able to realize with me why time efficiency is important? And you have to start thinking and consider them from the start. So because the thing is, real-time applications are mostly demanding in terms of speed. So basically, if you are designing applications, you have to think about loops, because loops kind of impact the speed of your system. It kind of has a cost involved in it. For example, you're using certain sorting algorithms, right? So it has a cost, it has an impact on the speed of your application. Similarly, remote operations, they are really, really impacting the speed of your application. Like if you have a client server architecture and you're making a lot of communication and data calls to your database server or remote servers, of course it has impacts. It also be impacted by the speed of your bottleneck, or what you call the bandwidth of your network, and so on and so forth. And of course, the functions cost. The more the functions cost you're going to have, the more costly it will. So you as a designer, of course, object creation is also a cost. All of them add up. They all add up. And you as a designer have to think about all of them. And of course, you try to think about, how I can minimize speed issues here. How I can, minimize loops cost on the speed, and so on and so forth. Now, of course, for a given problem, you have to use loops. Of course, you have to use remote operations. You have to create objects. But the whole idea is you don't create unnecessary loops. You don't create unnecessary functions. You don't have unnecessary method calls, so on and so forth. So far, so good?
Yes.
Yes.
Cool, cool. Alhamdulillah. Okay. Again, you look for some kind of a trade-off, right? And you basically, you're gonna, for example, try to see a trade-off between number of remote method calls versus, retrieval at each call, and so on and so forth. And you always try to kind of come up with a near optimal solution where you minimize the number of remote calls, and at the same time you somehow maximize your retrieval of data in those calls. Now, in addition to time, the storage efficiency or the storage dimensions of the efficiency is also very important. So as a designer, you have to keep in your mind that sometimes you only have to store the data which is absolutely necessary, because there is a cost involved in storing the data, and as compared to time it takes to remotely store it and extract it. So it depends on your solution problem. It depends on your context. And you as a designer have to think about it, that what information I should be storing. Should I be compressing data? Because again, compressing of a data has a trade-off, that if you don't compress it versus if you compress this, that you have to consider the time it takes to uncompress it and decompress it. And similarly, store them in a relative use of frequency. Like if some part of the data is used frequently, maybe you need to store it in a different way as compared to the rest of the data, and so on and so forth. Now, let me give you an example here. Let's say a mobile development application. In a mobile development application, the time and storage efficiencies are such an important factor for you as a designer. Let's say storage. There's a limited storage you have on your mobile devices. There is a limited power you have on your mobile devices. There is a limitation on the kind of bandwidth capabilities you have on a mobile network. So, you have to think about how much data I'm going to store locally on a mobile device. And if if I have a limited storage capacity locally, then what should I store? What is the most useful information I'll find from a storage perspective, because it has a benefit for you that the local storage will not have any impact on your time constraint, or time efficiency, and so on and so forth. So all of these points you need to consider. Are you able to visualize this with me? That on a given application, you have to think about efficiency as well. And you have to think about space. You have to think about time. Right? And these are key things for you as a designer. Any questions on this, guys? As a concept.
It's clear.
Good, alhamdulillah. So again, people do a lot of trade-offs. They look at many things and they try to, sometimes they will say, okay, I'm going to use extreme programming approach, the agile approach, and I'm only going to design what is really absolutely necessary for me. And then I'll refactor my design, and I'll see, if the time is an issue, I'll refactor it accordingly, or space is becoming an issue, I'll refactor it accordingly. Or sometimes, flexibility is important for you. This is the ultimate thing for you. So you basically design in a flexible way, or maybe you say, no, robustness is important, or reuse is important, or efficiency is important. So basically, depending on the focus you have, you one of these attributes may have a higher value for you in a given system than others. But at the end of the day, you try to optimize a solution between them. I'm just going to give you another very simple example here. Let's say I design a system where I put everything together in one class, right? All the functionalities, I put them. Now, of course, this is a nightmare from a flexibility perspective, right? Because if I'm going to make a change here, right, in one of them, I have to really, really make sure that it doesn't impact other parts. I can improve my design from a flexibility perspective by having inheritance, I can aggregations, separating with different classes. And with the help of this, and even I can have interfaces and so on and so forth. And with this, I can make change here without really impacting the display, for example, or make a change in display without really impacting the functionality of add, multiply, and divide. And this is what the whole idea is, that, don't try to mix everything together. Try to segregate them. Try to, once you're going to segregate them, of course, it's going to help you in your reusability as well. But don't segregate it too much, because then it will have problems for you from a time execution perspective and so on and so forth. As we move along in the semester, we will learn good design techniques, and then we will also learn design patterns, and they will kind of, we don't have to reinvent the wheels. People in the industry have spent significant amount of time coming up with some rules of thumbs for us, and as long as we follow those rules, we will come with a solution which will be good enough from a flexibility, reusability, and efficiency perspective. So in a nutshell, we want our designs to be flexible. We want our designs to be reusable in a given system if this is important for you. And of course, we're always interested in efficiency, both from a time perspective and space perspective. Cool.
Yes, cool.
Alhamdulillah. Perfect. Yes, any questions, please?
Doctor?
Let's go ahead, please.
Does efficiency in time also considered as when developing the program?
So should I consider time efficiency during my development?
Yes.
Yes, absolutely. Like, for example, in mobile applications, right? Your design can really impact the way it will have an impact on your time efficiency, the execution. Because if you're going to have a remote access, a lot of remote accesses, this means you'll be using the bandwidth. And then if you have a limited bandwidth, for example, right, or you're retrieving a large amount of data for every operation, then definitely it will have an impact. So these are the things you as a designer really have to think about. And for certain applications, it's like really, really critical. Because you will always have some applications where space is no issue, time is no issue, right? Because you have enough computation power with you. But for some applications, you have a limited computation power, you have limited space, you have limited bandwidth. Then you cannot afford to have a design which is designed poorly from an efficiency perspective. So we are very much interested in this. And this is a very common problem we face. Okay. Yes, please, go ahead.
The thing is that I just wanted to say that if time in development, while I develop the project, is it considered as efficiency? Like if
sorry, now I got it. Yeah. No. So the time it took me, for example, in a man hours, or whatever the unit I take for constructing the application. No, we're not interested from that dimension. No. That will be probably from a project management perspective.
Okay, thank you.
You're welcome. So here we're talking about the efficiency in execution of these systems.
Doctor?
Yes, please.
So about efficiency, let's say that you're trying to solve a problem, like implementation problem. So normally, or at least what's normal for me, that when you're trying to solve a problem, you don't care about efficiency or time. You just want it to work, and then you clean the mess you made.
Yes.
Is that a good habit, or is there anything that you advise us to do?
Now, the one you just mentioned is actually this approach, like an agile kind of an approach. right?
Yeah.
And for a given system, if you're following kind of an agile kind of approach, it will probably work, right? Of course, it will have impact on refactoring, so you will have to refactor it, right? Few times to clean the issues, right? And sometimes the thing is, sometimes you will be so experienced, and that's why, you know, especially for architects, I always say this, that you know, it comes with experience. Design also comes and improves with experience, especially when you have a lot of experience in programming and you have a good understanding of different solutions and structures and frameworks that, you know, probably with more experience, you will not tend to do the same mistake, and you will not be doing the same refactoring. But yes, it's absolutely fine. This happens in the industry. That's why you have evolution.
Yeah.
Yeah, and the more experienced you will be, probably, you know, you will not, you will go and do it the right way in the first time.
Yeah, clear.
Okay, so I think with this we can move on to the next half. I am assuming here that you guys can see the screen, right?
Yes.
Yes, we can see it.
Yes.
Okay. Now, so far what we have done, now we're actually entering into another new phase of the course now. Okay, so we have covered the basics of the concepts. We have understood, you know, the basic class diagram concepts, the basic four design principles, concept of abstraction, interfaces, use of inheritance, polymorphism, abstraction, encapsulation. We also have an understanding now that, you know, we have to design our systems keeping in mind flexibility, reusability, efficiency, and so on and so forth. Now, if you recall in the very first lecture, I said that, you know, there are two levels of design. One is your architectural level, the other is your detailed design level. Now, since it's the core course, so basically, you know, we will be looking at some, of course, we'll be looking at the basic concept of architecture anyway, and then we're going to look at some styles. And when I say some styles, because I'm going to try and cover some primitive or basic styles in 316. And I'm going to show you some examples of, you know, some more advanced architecture styles as well. Usually when it comes into our elective course, which I teach for 16, our focus is purely on architecture. We go into a lot of details, but here in 316, because we have to cover about, you know, detailed design, we also have to worry and understand design patterns, refactoring, construction. So I'll be giving you some fundamental information about architectures, right? And hopefully, if you are interested in this in more detail, and once we offer 416, you know, we can look at it more details as well. But inshallah, it will give you enough information from a core software design and architecture perspective. So again, we're going to try and understand what software architecture is, and then we're going to look at styles. Now, here, I like your special attention. Now, of course, I like to do this face to face, but we have to live with the constraints we have here. So I'd like you to just, you know, visualize with me now. I'm going to use a bit of analogy here with the civil engineering, and I'm going to, you know, kind of give you a typical scenario that what happens in architecture, civil engineering perspective. And then we're going to use this example later on in our lectures to basically, you know, understand some concepts. Now, imagine with me that, you know, in your whole life, you have only seen one-story houses. Okay. So do you need do you face any need for people to move between different floors in a house? Because you only have one-story house.
No, they don't need.
Exactly, they don't need, right? So there is no need for finding a solution for people to move from one floor to another. Now let's say next we realize that we are not really using our roof right, so probably we should we try to use our roof for barbecue or something, you know. So now the problem arises that how people will move from first floor to the second floor or from the ground floor to the first floor, right? Hence, you need to come up with a solution, and as a civil engineer or as an architect, you come up with a solution of stairs. And it will work, isn't it?
Yes.
Absolutely. So there was a problem which arose, and you come up with a solution of stairs, and it started working. Then you said, okay, you know, maybe we need to have, you know, one-story house is not good. Maybe you know, space we can use better. Have 3-4-story houses. Will the stairs still work for people to help move people from one floor to another?
Maybe.
Yeah, probably yes, probably right. 3 stories, probably it will work, right? So though you are expanding your system, your houses, the structure, but probably the same solution is still working. Now let's imagine. Now you say, no, I'm going to have 10-story houses or apartments or building. Is stair still the most feasible solution for moving people?
No.
Not anymore,
No.
right? Not
No.
anymore. So you as an engineer come up with a solution, and you said, stairs are not good enough. It used to be good enough, but it's not good enough anymore. I need to maybe come up with a new solution, and you bingo, you say elevators, right? I'm going to come up with elevators now. It will solve the problem. It's a better solution. And that solution is there. You move from 10-story houses to you start building 20-story buildings, 30-story buildings. Elevator is still working fine. The problem is not anymore. Then all of a sudden you are in a situation where you have to develop Burj Al Khalifa now, right? With this elevator solution, the typical traditional elevator will still work in that model.
Not anymore.
Not anymore. And you start have thinking about solution as an engineer, and you said, okay, maybe, you know, I might have to divide my elevators into different floors and say that elevator number 1 will only serve the first 10 floors, the elevator 2 will only serve the next 10 floors, and so on and so forth, right? So this is a natural, typical thing which happens in civil engineering. Same thing happens with us as well. From an architectural perspective, over the years in our industry, as the systems were smaller, the people came with certain architectural solution. Then the systems grow, new problems arise. They strive to solve those problems, and new architectural styles keep evolving. And then, you know, for you as a as a software engineer, you know, as long as you know those basic styles, probably your problem will be solved. Like the example of elevator, you don't have to reinvent the wheel. Elevator solution is there, you use it. So same thing will happen with us. We will learn some styles. Those styles will work for your application. And if they don't work, then you can combine those styles, like, you know, combination of elevators and stairs. And then sometimes you might have to think completely out of box to come up with a structure which solves your problem. Okay, so you know, the reason I share this example is because this kind of tells us that, you know, sometimes some solutions which are already developed by the industry will work. You don't have to reinvent the wheel. You just need to know them and use them. Sometimes you might have to evolve them, and sometimes you need to completely think out of box to solve your problem. So far, so good.
Yes.
Everybody on board with me here, right?
Yes.
Right.
Cool. Yes. Okay. So I think only 2 minutes to go. So probably I'll stop it here and I'll talk about this analogy and more into detail about what an architecture is, inshallah, on Tuesday. So I just wanted to comment on the project. So I'm pretty sure everybody has signed up for the. I haven't checked today. Everybody has signed up for the project teams. Hopefully, yes. Hopefully, I saw maybe there were 1 or 2 teams with 2 members. So if this is the case, probably I'll merge them with another team with 4 members or something like this, right? So if you have not signed up, kindly do sign up because we like to start the project from Tuesday, inshallah. And if this is what the teams are, then I'll inshallah randomly merge some teams so that we have a bit of a balance between the team structure, because you can't do a project with 2 team members. I hope there's no concern with this, right?
All good.
All good, inshallah. So yeah, basically I'll create a pool for the to come up with a better suitable date for the assessment. We'll try to do one trial assessment for 5 minutes maximum. We just want to make sure that everybody is comfortable to use some drawing tool to draw and upload. And we'll start the project from Tuesday. I'll talk about the projects, inshallah. We'll talk about this architecture. Fun stuff coming up, guys. Architecture will be fun, inshallah. And we'll be looking at different architecture styles, and we'll try to see, how one style is better than others, and so on and so forth. So I'll stop the recording here, and I'll take the attendance, and inshallah